Okay, now we'll go through how to find out that mean average precision. We have to go through that quickly. So let's say you have this image, and yellow colors are the ground truths, and you have something. Let's say you have an object detection algorithm which detects like the red box is the detection. Now, do you say that this thing, this detection is good? Yeah, it is able to detect out a human, but it is not good, right? Imagine this thing being used for your autonomous cars. It will be mass destruction. And if you go for something like this green box, it is also not that good. If you go for this blue box, it is detecting a person, but it is not fully detecting the person. So how will you decide which bounding box given or predicted by your algorithm is good? So that also comes in with this only intersection or union concept. So you will decide a threshold on it. Whatever bounding box it gives, let's say this is the bounding box given by the algorithm, the red one, and this yellow one is our ground truth. You will decide IOU threshold on it. So you will calculate intersection of these two bounding boxes and also union, and you will divide and you will take that fraction and you will decide on the threshold. If it is greater than that threshold, you will say that it is correct. So you can see this one, this will have an intersection over union lesser. This will be having intersection over union lesser than the first one, and this will be having more, right? So yeah, so if you see the green one and the red one here, that means it is a good match. The prediction is good. Green one is our ground truth and red one is the what the algorithm has predicted. And since the IOU score is more for it, it is good. We can say that this is a true positive. Now, if you guys are aware of precision and recall concept, in here, your precision will be true positive upon region of interest proposals. So let's say you have this red boxes as your proposal boxes. So what you can have is all the true positives. Okay, whatever the algorithm has given and which follows the intersection or union threshold, those boxes will be coming under true positives, and region of interest proposals will be having all the proposals, this all red bounding boxes. You can divide them and you can get the value for precision. For recall, you can have the true positives, like whichever bounding boxes the algorithm has given and are correct as true positive, divided by all the ground truths we have in that image. So here we have true ground truths, right? I guess I'm getting too fast on it, but yeah, manage with it for now. So yeah, this is how you get the precision and recall. Let's take an example because we want to see how the map term is calculated. So let's say we have 7 images. So in one image, you can see these green boxes are ground truths and red boxes are what the prediction, what the algorithm has predicted. And beside that, you have been given the confidences as well. So how do you proceed for it? How do you calculate map score for it? So what do you do is, first of all, you can see here we have the image indexes, image 1, image 1, image 2, image 2, image 3, image 4. And inside that, you go for the first detection. You can see that for the A, something which is detected, which we have labeled as A, it has a confidence of 88%. But you can see that it will not follow the IOU criteria, right? If you calculate the IOU for this thing, it will be too much less. At least if you have the option to select it, you might be keeping it 75%. But here you can see the IOU score will be too less, and that's why it will be something which will say at false positive. Algorithm says that this is your detection, but it is false, and that's why it is termed as false positive. Similarly, all this image will be having these things, will be having the confidences as well as will label that whether it is a true positive or whether it is the false positive. So something like this B thing, in the first image, you can see the ground truth and the prediction, they are overlapping with each other and they are having a high IOU score. And that's why we'll say that it is a true positive, and that's what we are labeled as true positive. So you have to create this thing. After that, what you can do is take the same thing and arrange it in decreasing order. Okay. So you can see 95%, which was at the bottom, it came at upper side. Okay, it came at upper side, and here, and one which was having a lower confidence like 14%, it came at the downward side. And then what you have to create a new column that is known as true positive, false positive. So what is true positive? Wherever this image is actually that bounding box was having the label as true positive, just have a one in front of it, and if not true positive, if it is a false positive, you have a 1 there. Then you have to find out accumulation of true positives. So what you have to do is you just have to add. Okay, we have just a few slides left today now. Just 5 to 6 slides we have. Just bear with me. Okay, so what we have the confidences arranged in decreasing order. Then we have true positive and false positive notation. Then we have accumulation of true positive. What you can do is just add this thing, right? Whenever you move from up to down, how many true positives do you have? So for first example, you have a first true positive, just 1. In next example, you have just 1 false positive. So you have the accumulation of false positive as 1. When you move downwards, you will get again a true positive, so it becomes 2. Then you have to find out the precision and recall. So how will you find out precision and recall? Precision is true positive upon true positive plus false positive. So you should be able to you should be fine with calculation of that, right? You have true positive for that row, you have the false positive for that row. Just do the calculation, true positive on true positive plus false positive, you can get the precision. For recall, what you can do is true positive upon number of ground truth. So how many number of ground truth we had? We had something like 15 ground truth here if you count. So you can do that thing as well here, and you got the precision and recall columns. After that, what you have to do is you just have to plot them, precision across recall. You plot them together. Now the thing comes is, how will you find out map score out of it? So where did we start? We started from here, then we came decreasing order, then we had the columns known as precision, recall, and precision and recall. Then what we have? Then we had a graph, right? Now we have to now we have to find out the map score out of this graph. How will you find out the map score out of this graph? There is some method known as 11-point interpolation. What you have to do is you just have to take recall on the x-axis and precision on the y-axis. What you can do is just plot this points on this graph. Somewhere you might have the repetition, like 0.133 is coming again and again. Yeah, I know we are going far beyond the time. Yeah, just bear, just 2 minutes for it. So yeah, so you can see, yeah, 11-point interpolation method is used for finding out this graph, and you can have area under it. You can see the values of it. So what you can do is just 1 by 11 and all the values for this x-axis coordinates, like 0, 0.1, 0.2, 0.3, 0.4. Add them together, divided by 11, you will get a score which is known as average precision. And now we don't use this 11-point interpolation. We have all the new computations which are there, like COCO dataset and Pascal. They use all point interpolation. What do? We just find out the area of them, and that gives us average precision. This comes closer to it only, 26.84 and 24.56. Next thing is, this is how it is used for measuring the accuracy. Let's see. This is a fast RCNN, and it was trained on Pascal dataset of 2007, and the mean average precision it got was 66.9. And again, you got this fast RCN which was trained on the data of 2007 as well as 2012, and you got the mean average precision as 70. And similarly, when you move forward, you have faster RCN as well. So you have the choice whether to train on a single data set, or you can train on the combination of data sets as well. And after that, you can have the mean precision accuracy. You can find them. And yeah, so what we have seen frames per second. We have seen mean average precision accuracy. Okay, so this is what is important. You should know algorithm should be having more frames per second processing, as well as higher MAP. So you find out average precision for all these categories, and you take a mean of it, and that becomes mean average precision. For the checking purpose, for COCO dataset, it is something different. What they do is they take out mean average precision for IOU threshold of 50, 55, and 95, like a difference of 5%, and they take an average of it, and that becomes the average precision for it. For every algorithm, you can see here, for faster RCNN, which has the ResNet as its backbone, you can see the average precision. This is AP50. I want you guys to know this thing, because whenever you're gonna read this kind of papers, you will be confused with what is AP50. So 50 means the threshold what they are allowing for IOU. So more lenient you go for the threshold, the higher will be your accuracy coming out. So here you have given the 50 as your IOU, but and your accuracy is improving, but that is not good. If you become stricter on your model, like 75% as your intersection or union, it will reduce down your accuracy. And this is how you can see the average precision on small, medium, and large scale objects as well. Okay, now we are done with our slides. I guess you guys enjoyed. It took some more time to complete the slides.